Hello everyone and welcome back to another video. Today we'll be taking a look at another British Informatics Olympiad question, and we'll be taking a look at the 2018 paper and the second question from it. So let's have a quick look at the question first. This is a relatively small question compared to the usual size, but if you want to have a quick read, I'll just let you read it right now. Feel free to pause the video if you want. Okay, so and now I'll just jump straight onto the program, since there isn't really much to do on the whiteboard, since the question's pretty clearly laid out exactly what function order we need to perform everything in. So let's have a quick look at the code now. Pretty much, there are going to be a few main functions, well, two main functions. The first one is generating the original shuffling arrangement of the queue. And then the second one is going to be actually encrypting the words, and then just printing out each word, each letter in its encrypted version. Okay, so both of these can be implemented relatively straightforwardly compared to the usual size and complexity of question twos. But I'll just quickly walk through how exactly we do it. So the first one is we basically need to initialize some sort of the initial alphabet, basically. And what this will be is this will be the ASCII. If you don't know what ASCII is, it's basically the internal representation of each of the characters. Each character is a unique representation. So like capital A, for example, is 65, and then lowercase a would be 97. Each one has its own unique number representation. So it's basically the ASCII values from 65 to 91. So what these are is, this is basically just generating all the capital letters. I could have all just spelt out capital A, quotation marks, B, etc. But this is just a bit more of a sophisticated way of doing it, I guess. So this is the initial alphabet, and this will come in handy later, since we basically use the initial alphabet to generate the new queue. And our code relies on two main queues, and the queues are basically Q1 and Q2. And what they are is Q1 is basically the first queue which we have, which is basically the original, it's just the alphabet. But then the second queue is going to be the shuffled queue. And then each of the corresponding letters in Q1 will then be encrypted to one in Q2. And the main feature of this code is we'll be using DEQs, or DQs if you like, double-ended queues. And they're really useful for the rotation property which they have, which, as you can see, we've used extensively throughout this code. So now let's just walk through line by line the rest of the code. So we basically just take the input of n and word, where n is n will be useful in shuffling, but it's basically n cards means that you rotate until you reach the nth card, and then you select that particular card, pop it out of that array, and then append to the new array. So that's what n is useful for, and word is the word which we need to encrypt, obviously. So initially we basically we create a copy of Q1, and then what we do is we initialize Q2 to being just an empty DQ. And then what we do is we basically, while the length of the initial alphabet is greater than 0, so this means that while there are letters still remaining within the original alphabet to encrypt, what we do is we basically, initially, we set temp n equaling n mod len initial alphabet. And now I'll come on to why exactly we did this in a second. It will probably make a bit more sense after I go through these couple of lines first. But what we do is we basically just, for iron range n, effectively, we can just treat temp n as n for now, and then I'll come on to what it does. For iron range n, what we do is we basically rotate n minus 1. So what this feature of double-ended queue does is rotation basically means that each element is given an index value which is 1 greater than whatever its current index value is. So that's what rotate does. So then rotate minus 1 means that it rotates left. So that basically means each value is given an index which is 1 less than whatever its current index is. So we basically rotate minus 1, which is exactly what the question asks for, since the question basically tells us it basically rotates clockwise, which is what this rotate function does, which is why it's so useful in this code, since we don't need to write our own one, for example. We can just use the double-ended queue property. And then what we do is we basically, after rotating, we pop we pop the first element from the initial alphabet, and then we append that to Q. and then we basically effectively repeat this 26 times. And now let me get on to what temp n does. So pretty much the n value can be extremely large, as specified inside the question. If I just go back to the question, n can be anywhere from 1 to 1 billion, 1 trillion, like some very big number. But point is, we are only interested in what the value of n is, what the remainder of n is when divided by the length of the alphabet. And now the reason why is because if we consider, if we have some n which is greater than the length of the initial alphabet, then that will basically correspond to it rotating it more than the required number of times. Since let's say the initial length of the alphabet was 25 and n was 100. So it would basically rotate 25 times 4. It would rotate 4 times the entire array. So that basically, like after 25 rotations, it's exactly where it started off. So we can just take mod initial alphabet length. Since like we're only concerned in whatever the remainder is, only those will be the valid rotations. Okay, so that's pretty much why we carry out this rotation function. And then after that, okay, and now one more key part of the code is this particular line number 11. Now the reason why we do this is because n is basically in one base, right? Like in one based indexing. Since let's say n was 5, then it would be the 5th element. So it would be n equals 5. However, our code relies on 0-based indexing. So which is why we basically need to subtract 1 from whatever the value of n is. However, we need to basically do this, but mod length of the initial alphabet. This basically avoids going into negatives, since if it were negative, it would just wrap back around, and then it would go to whatever the correct value should be. So the first time I coded this, I basically forgot to do this, and then I wasn't sure what my error was. And the reason why is because of the discrepancy between 1-based indexing of the input versus 0-based indexing of our actual array. So that's basically this particular function which shuffles it. And then the second function which we have is actually encrypting the words. And now what we do is for each of the characters inside the word, while the first character is not equal to the character, so what this means is while the first element inside the queue, the first queue is not equal to the character which we currently want to encrypt, we keep on rotating until we reach that particular element. And once we reach that element, then we output the corresponding value in the second queue. And then we just print and we just print nothing on the end. That way the next character can also be printed on, like it basically just a formatting thing. But then this bit of code is quite key. So we basically keep on rotating the first and second arrays until the first element of the first array is equal to the character which we want it to. And then after we're done with all this, then we finally perform one more rotation, as the question states. And then we basically just repeat this for each of the characters inside. So that's pretty much it for this particular code. Let's see if it actually works though. So let's give it some test case. If we go back over here, then what are we'll give it the very final test case. So I mean, if you notice this very large number, we have like 9999999. Our code basically outputs instantly, and the reason why is because we take mod of the length of the initial alphabet. This basically saves us loads of unnecessary computation. Like if we were to not do that, then this would have taken like several minutes before it actually works. But with this particular code, it does indeed give us the correct answer. And now we'll just test one more one. We'll test the penultimate one, elephant. And then if we go back to the question, this does indeed give us the correct answer once again. So that's pretty much it for this particular video. I really hope you enjoyed watching. Hopefully you learned something new about how to, maybe it's about the modular arithmetic or how to use double-ended queues in a question like this. If you enjoyed, please be sure to leave a like and subscribe. Also, you can check out my GitHub if you would like to do so. And I hope to see you in another video next time. Thank you very much for watching. Bye.